are going to demonstrate acid-base titration. I want to show you what acid-base titration looks like. All the procedure involved, and as well as the precaution to be taken while carrying out acid-base titration. First of all, I will introduce the acid-base titration apparatus, and then I will assemble them one after the other. And then while assembling them, I will be telling you the precaution to take for every apparatus. The first one I have here with me is a Ritter stand. We use the Ritter stand to hold the burette vertical. So you open the clamp of the Ritter stand. You check two things. If you look at this clamp, it has a pad inside it. If you look at this clamp here, there is a pad. If you check the clamp of the Ritter stand, if there is no pad, you use either a pepper or a cotton wool to pad it, so that when you tie it here, it will not break the burette. This one already has a pad in it. Assuming it does not have a pad, I will pad it up so that it won't break the pressure. The force will not break or crack my burette. Now I have to tighten it so that it will hold my burette vertical. Alright. The next one is to place my white tie. You know the reason for putting this white tie? For easy identification of color change. We need a white background for easy identification of color change. Now, the instruction says we are to fill the burette with solution A, which is the titrant. We fill it with solution A. So, we have solution A in this container. Then I will use a beaker labeled A to collect it. This is solution A. Now I place my funnel and pour solution A. Remember, one of the precautions here says you rinse the beaker and the burette with the solution. I've already done that before you came in here. So I've already used this before. So I've already done that. So one of the precautions, you rinse the burette with the solution you have to add in it. Likewise, the beaker you use to collect solution A, you rinse the beaker with solution A after washing it with distilled water. Are you getting what I'm saying? So that is number one thing you have to keep in mind. Taking note of the precautions, very, very important. Now, I want to reduce the volume so that it will come to zero calibration. Now, you press a ball. There is a ball in this rubber tube here. The ball is what you press, and then a liquid will start dropping out. For those of you that will ask me, how are they going to make the liquid to start dropping? Maybe you are not aware that you don't use clip for burette. This is it. The standard burette format makes use of a ball instead of clip. That clipping is improvisation. If you see anybody using clip to hold a burette, that person is just trying to improvise. Maybe there is no ball in the tube. That is why I have adjusted this to 0 right now. So I remove this one. That's the first step. Then another step is to get my solution B. This is my solution B. get some of it, collect some of it in a beaker, and then I will now pipette 25 ml of it using my pipette, and then pour it in my conical flask, and then I will now add an indicator. Now, these solutions I'm using for this titration, the name we are not reviewed, but by the time we start solving questions that comes with it, maybe we may see the name in the question. But for now, the choice of indicator we are to use is methyl orange. So let me get the indicator. Methyl orange. This is the indicator we are to use. So when I pipette 25 ml of the base and pour it in the conical flask, I will now add 2 drops of indicator. Now, if you are close enough, you will see that I have pipette to the calibrated region. So I now introduce it in my conical flask by opening my hand, so the thing will now go. Another precaution of using pipette, you don't hit it in the wall of the conical flask just for the last drop to enter. Rather, you place it to touch the wall. You don't hit it, come. No, you just place it. Once it touches the wall, the last drop will enter quietly. You do it this way to avoid breaking the tip of the pipette. Now I can go ahead and introduce my indicator. 2 drops will be fine. 1, 2. If you look at it, the solution has changed to yellow, telling you that the methyl orange indicator is yellow in a basic medium. That is why it's yellow. We will now titrate the acid, which is the titrant, against the base, which is the titrant, until we observe a color change. Once we observe a color change, we will check the volume of acid used to neutralize this 25 ml of base that is inside this conical flask. Now, at this point, we start to release the acid and introduce it to the conical flask, and then we shake as we are doing it, so that the mixture, the titration mixture, will have a uniform concentration. Do you observe anything?
Yes.
Was that any color change?
Yes.
Has it changed?
Yes.
All right. From my reading here, remember, another precaution to take while taking a reading from your burette is to make sure you take your reading at the concave meniscus and also at eye level. From what I'm seeing here, the volume of acid used is 25.2. Volume of acid used is 25.2. So, I don't have any writing material. I wanted to do something. Do I have marker? Anybody with marker?
Compare first.
In this table I have burettes reading is cm cubed. I'll now have final reading. I'll now have initial reading. And I'll now have volume of acid used. I can now have my rough here. I'll have my first titer, my second titer, and my third titer. Don't know why you are making noise. My initial for the first one was 0.00 and my final was 25.20. Now I want to repeat it again to go to handle another titer. Then I'll now pick my burette and my pipette and pipette 25 ml again. At this point, I introduce it in another conical flask. And at this point, I introduce my indicator again. You see that both of them does not have the same color, right? And if I ask some of you now, you tell me that this has to be pink. And I've told you, whenever you titrate using methyl orange and you have a pink color, you're already wrong. It shows you have added excess acid. Now let's titrate again until we get this orange color. That is our end point. This is yellow, this is orange. Alright. Then you remember we have I would like to fill the burette again to zero calibration because I am not sure what is left here will be able to neutralize this one. To avoid guesswork, I may choose to fill it again. And when I fill it again, my initial will now become 0. Are you there? I will prepare another.
Betul.
All right. We now run the second one. Huh? Has it changed? No. It has changed, right? Okay. I have my reading at 25.9. Second one. Remember, I filled to the zero calibration, so my initial here will now be 0.00, and I'll have 25.90 as my final for this second one. So let me get another two. Then I'll prepare another one for the second, right? I add another indicator in it. Then I refill again. Remember, each time I'm refilling, I'm taking the calibration to what? 0. So my initial volume of acid will be what? 0. Remember, one of the precautions, you avoid air bubble. You avoid air bubble in the bullet. Alright, let's do this one again. See how it's going to show us. Has it changed? Yes. Has it changed? Yes. Should I add more? Yes. Has it changed?
Yes, add.
Do I need to add more? Yes. Or it has changed? Yes. There's something I need to tell you. Whenever you observe a color change, you don't have to add again. Is that clear? Yes. So I'm going to take my reading from here. If you look at it, all of them are still orange. Okay, so, so now I have 24.8. I have another reading here to be 24. This one did not even reach 25. So I have, remember, I fill it to the 0 calibration. So I have 0.00 here. This one is 24.80. Now let me do the fourth one. In fact, I will just take the, once I'm done with the third one, I will now show you how to pick the titer you are to use for your average. Let me just finish this last one. Alright, in this one, I will not refill the bullet, so that my initial will be 24.8. Are you getting what I'm saying? Let's see how this one will play. Add an indicator. Of course, some of you that were telling me to add more, is two of them the same? To tell you that something really happened. There was a color change. You can see it, right? Alright. Now let's go. I said I will not refill it. That means our initial for this one is 24.1. Alright, let's see what will be our final. Has it changed? Has it changed?
Yes.
It's still yellow, right? So we add one more drop. We add one more drop. It has changed, right? Is it in excess? All of them still give the same. Yes. Okay, let's take our reading. So let me bring this thing up so that the thing will be on eye level. So that I will be able to take the reading at my eye level. Okay, this is a 46. This is 46. Yeah. 46.0. So I have 46.0 here. Alright. After doing all this titration and recording our reading, it is important to look at our table. First of all, we bring the value down by subtracting the initial from the final. And if we subtract 0 from 25.2, we have 25.20, right? The same thing here, we have 25.90. Here we have 24.80. So subtract this one and tell me what we're supposed to do. Huh? That's not 22. 21.20. Alright, now let's look at it this way. We want to choose the value that are closer to each other and take average. Among these four values, which of them is more closer to each other? 25 and 24, right? Okay. So one can say, okay, I would like to choose these two and then divide by 2. Are you getting what I'm saying? One can say, okay, since this one is a little bit out, I can choose to add 1, 2, 3 and divide by 3. Are you getting what I'm saying? But for this result to be more accurate and precise, there's no point including this one that is a little bit outrageous to what we have. Even if you look at the color intensity, the orange color of this, you will see that the color intensity is even telling us something about this reading, right? Yeah. Look at this one is more intense. This is our 25.9, the second one. This one is lighter, right? This is our 21.2. Okay, so but what matter is that there was a color change, right? Now I may choose to pick these two because it gives me exactly what I want, right? I can use it to calculate my average volume of acid used by saying 25.20 plus 24.80 divided by 2. That gives me what? That gives me what? I have 25.00 centimeter cube as my volume of acid used. So with this, my result is very, very accurate. Do you know why? Don't worry. When we answer the questions that follow this titration, you will see why. You will see why. We are going to answer the questions that follow this titration. Thank God I did it myself now. So when you will be doing the same thing, try as much as possible to get this. It must not be today. But when you will be, I'm going to group you. When I group you, you are going to repeat exactly what I did now. I'll give you titrant and titrant. The acid and the base we titrate. And what I'm trying to tell you is that whatever you are doing, be careful enough so that at the end of the day, you will be able to get the volume of acid used to be something closer to this value. You know, the closer the number, the value you have, more accurate, right? And we want your result to be very accurate. I believe what I just explained now is very clear. Simple acid-base titration. I believe it's very, very clear. So if I ask you to do this, you can do it on your own without help. All right, thank you very much and God bless.